Alright, so today we're going to talk about how to write proofs using these parallel lines. So first we're going to prove those three parallel line theorems we discussed before, alter interior angles theorem. So given lines G and H are parallel, when you use it to prove that angles 1 and 2 both must be congruent. So we'll set up our two-column proof, where our first statement is our given, G is parallel to H. Now, if these two lines are parallel, one thing we're allowed to say is we can't say any one of those theorems until we prove it. We are allowed to say, though, the corresponding angles are congruent. It's considered a postulate, so we don't have to actually prove it. So angles 2 and 3 are both corresponding angles. So therefore they're congruent. Now, I want to say angles 1 and 2 are the same. So if I can relate angle 1 and 3 to each other, I can then relate 1 and 2. Well, 1 and 3 are both vertical angles, so they must be congruent. And because both angle 1 and 2 equal angle 3, they must equal each other. That's our substitution property. And this right here is going to be the general gist for most of the proofs for today. We're going to use the corresponding angles postulate to talk about given parallel lines, what that tells us. We're going to look for either vertical angles or linear pair angles so that we can then relate it back to the ones we want to work with. Alternate interior, alternate exterior are consecutive interiors. So the alternate exterior angle theorem, we're given lines G and H are parallel. We want to use it to prove that angle 4, it should say angle 5, are congruent. 4 and 5 are alternate exterior angles. So again, G is parallel to H, that's our given statement. We then want to look at, well, 4 and 6 are both congruent because they're corresponding. Always look for those corresponding angles. Again, your F's in the diagram, very useful. And then again, look for your other stuff, your vertical angles, your linear pair angles, because 5 and 6 are both vertical angles. And since 4 and 5 are both equal to angle 6, they must equal each other. That's our substitution property. So you'll find your alternate interior and alternate exterior theorems, both for this case, and then when we prove the reverse, angles congruent and prove lines are parallel, will be pretty much the exact same processes. Start with your corresponding angles, go to your vertical angles, that relates to the two angles we want to relate to. Consecutive interior angles theorem is a little bit different, because instead of proving angles are equal, we want to prove that angles are supplementary, meaning they add to be 180 degrees. We still always start off with our given statement, G is parallel to H. And since the lines are parallel, 9 and 8 are both corresponding angles. Well, I don't want to find vertical angles, because first off, I don't have any. I want to instead find a supplementary pair, because that's what I want to prove. Well, I know 7 and 9 are a linear pair, so I can say angle 7 plus angle 9 equals 180. This is my linear pair postulate. And since 9 and 8 are the same, I can replace angle 9 in this equation with angle 8. That's our substitution, and that's my last parallel lines theorem that we want to talk about. Consecutive interior angles theorem. So again, for all these theorems, the three we did today, so far, we want to talk about the corresponding angles first, lay it back to either vertical angles or linear pair angles, and then sub in what's equal. And again, from this point forward, anytime you see consecutive interior angles, you can automatically say that they're equal. So they add to 180 because they're consecutive interior. Or if you all have alternate interior angles, they're equal. Alternate exterior angles, they're equal. The key for all those is you have to be first told lines are parallel. If you are not told lines are parallel, you cannot state that those angles are equal or supplementary because of parallel lines. It doesn't work that way. So that's what we're talking about here are 4 converse theorems. Now the first one's a postulate. Accept this to be true. If two lines are cut by transversal so that the corresponding angles are congruent, then the lines are parallel. This is the one we're going to use most. This is the one that's going to help us show why two lines are parallel for the next three proofs we do. And we're going to go ahead and prove these three theorems. Alternate interior angles converse, that says if the alternate interior angles are congruent, then the lines are parallel. We will have our alternate exterior angles converse, saying the exact same thing, but now talking about alternate exterior angles. If they are congruent, then lines are parallel. And then finally ending with our consecutive interior angles converse, saying if the consecutive interior angles are supplementary, then those lines are parallel. So those are the three theorems we're going to work on right now, our three converse theorems, for a total of 6 for this unit. So first, we're given angles 1 and 2 are congruent. We're told our alternate interior angles are the same. We're going to use that to prove why G and H must be parallel. So we start with our given statements. Now, to prove lines are parallel, what we need to do is we need to go back to our corresponding angles converse postulate. So what I need to do is I need to show that my corresponding angles, angle 2 and 3 in this case, are equal by some other means, like a substitution property. Because once I know that they're equal, I know my lines are parallel. Well, if I want to show 2 and 3, I already got 1 and 2. Well, 1 and 3 are vertical. And because both angle 2 and 3 both equal angle 1, I can say angle 2 and 3 are both the same by my substitution property. Not because they're corresponding, because I don't know the lines are parallel yet. They're equal because of substitution. Because they're equal, and because they represent corresponding angles, this now means lines are parallel. That's our corresponding angles converse. That's the whole point for the two other proofs you're going to do in addition to this one. We must first show our corresponding angles are congruent by a substitution property, or something similar to that, to then say lines are parallel by the corresponding angles converse. So let's apply that same thing with our alternate exterior angles converse. So we're given the alternate exterior angles 4 and 5 are the same. Prove G and H are parallel. So we'll start that statement first, and then go on from there. So, 4 and 5 are both congruent. Well, we also know that 5 and 6 are congruent, because they are vertical angles. Now, since angle 5 is equal to both 4 and 6, 4 must also equal 6 because of our substitution property. And now, because I've found a way to show that 4 and 6, my corresponding angles are equal by some other method, this tells me then, if corresponding angles are equal, lines are parallel. That's our corresponding angles converse. Very similar proof to the previous one. Alright, last one to do. I want you to try and do this one on your own completely first. Try and set up the proof with your given statement first, and then try and find some way to show angles 8 and 9 are both equal using a substitution property or some version of that, so that you can then say lines are parallel. So go ahead and set that up, and then I'll show you my proof. So here's the proof that I made for the consecutive interior angles converse. So we first start off with our given statements. We then want to go with our linear pair postulates. I need to find some way to show 8 and 9 are equal, so I need to find a way to relate 7 to 9, so I can then relate 8 to 9. Well, 7 and 9 are both linear pairs, that's why they add to 180. So in both statements 1 and 2 add to 180, the equations must equal each other. So angle 7 plus angle 8 would have to equal angle 7 plus angle 9. That's our substitution property. We notice they both have angle 7s in them, so they're going to subtract out, leaving just angle 8 congruent to angle 9, again our subtraction property. I now have my corresponding angles congruent. Therefore, G and H are parallel because of our corresponding angles converse. And there's our abbreviation for converse. So that's for the actual class. So that's those are the 6 proofs that you will be responsible for this chapter. So that's it for today. We only have one more section left, and that is it. See you next time.